Hello friends! In this video I will talk about parametric modeling in SolidWorks. Parametric modeling is modeling using tables. When you change some values in the table, your model is rebuilt according to the values you specified. My brother has already recorded a video about parametric modeling in Autodesk Inventor. And in this video I will show you how to do it in SolidWorks. Let's start by clicking on the home icon. We'll create a new part. I'll create a sketch on the top plane. I'll draw a rectangle from the center. I'll set its height to 200 millimeters and the width to 150. Just like that. Now I'll extrude it by 50 millimeters. I'll create a sketch on this face. Control 8. Let's draw a circle from the center. Like this. Set its overall diameter to exactly 80 units. There. Now let's proceed to the features section and then carefully extrude our circular shape. I meticulously extruded my circular shape by a precise 80 millimeters, ensuring accuracy and a perfect fit. Like that. Right now, we can't see the dimensions we previously set for our part, its height, width, and other measurements. It will be more convenient if we display all the dimensions and can see which one we need to change to modify something in our part. To display the dimensions, I'll right-click on Annotations and select Show Feature Dimensions. Here are the dimensions. I moved them a bit so they're easier to see. This is an example of how it should be done, demonstrating the correct method. Here are all our dimensions. Now I'll display the names of all these dimensions. To do this, I will simply click on the small arrow located right next to the eye icon and then proceed to click directly on it. Now, the names of the dimensions are displayed under each one. We'll change these names so that we can later find them in the parameters table. To change the name that's currently there, we click on the dimension with the left mouse button and then change the name in this window here. I'll write base length. Base. It will be the base length. I'll just name this one base width. The overall base width. I'll call this particular one cylinder diameter for identification. Cylinder diameter. Here I'll just write cylinder height. Cylinder height. And for this specific and important dimension, I will proceed to set it as base height, which will serve as the fundamental vertical measurement for the cylinder. Like this. Here we have the official designation, which clearly indicates its specific purpose. There you go. I'll move all of this. There. Now I will proceed to carefully click the Insert button and then subsequently Tables. And from this point I will select. I'll choose the option to create automatically, and then I will leave all of the other settings as their default values. And now we click OK. We select all the dimensions we have here. It says, what do you want to add to the table? We add all our dimensions. Okay. Now, you can clearly see that all of our various dimensions and their corresponding names are prominently displayed right here within this interface. There. I will proceed to make the window a little bit bigger to provide a more comprehensive view of everything. Now you can easily change them. For example, here we currently have 200 as the base length, and I'll proceed to change it to 250. Like that. Now click on an empty space. The table updates and the dimension becomes 250. Our box gets longer. Now as you can see, our dimensions have turned pink because they are linked to the table. But you can also change them here without going into the table. If you change them here, the changes will be applied in the table. As you can see, when you change a dimension, a menu pops up saying that if you change this dimension, it will also change in the parameters table. I'll click OK. I can change it. I'll set the height to 95. It changed. Now let's rebuild. The recent change has been successfully updated. Now I will proceed to the configuration section. I will then open the relevant tables and subsequently edit the specific table. Edit table. It has been updated. Click OK. Now we have 3 distinct values of 95 for the cylinder height here. We can also effectively link some additional, important, and relevant values. For example, let's say we want the base length to depend on the base width. Suppose we want 2 base widths to equal 1 base length. Then when we change the base width, the base length will also change. To do this, we need to change one parameter. Right now, all these windows are set to display as text values. This means that it's as if some text is written here. When there's no need for any addition, subtraction, or multiplication, you can leave everything as it is. You can enter a value and everything will be fine. But in order to perform any calculations, we need to switch a special parameter. Right now, it's still set to text. Click on this little arrow and switch it to number. Now we see these hash marks appear. This means that the format is now set to numeric. Let's change the format in the next cells as well. Now, we can readily perform fundamental arithmetic operations such as addition, subtraction, division, and multiplication. For example, I will proceed to edit this particular cell and then write that this specific cell, well, the base length, precisely equals. Now, I can specify one of these numerical values. For instance, the exact width of the base. I will click this cell with the left mouse button and then multiply it by 2. Let's say, press enter equals. There, now we have this value here, and it's 300. Because 150 plus 150 is 300. Now, to exit the table, I'll click on an empty space and our changes will be applied. Now the length of the base equals the texts. And now I'll show you what would happen if our values were text. I'll go back to our table. Our table has been updated. I'll click OK. Here it is, our table again. All these cells. Let's select the text format. In this cell, we'll just leave C3 times 2, and then from here, we'll exit the table. As you can see, we have an error. I'll click Continue, ignore the error. This error appeared because here the size is 300, which is now displayed as if it's 0. I'll edit the sketch. I'll go to Dimension. Okay. Now let's open its value. Let's take a look at it. Here it is, 0, 0 millimeters. This happened because in our table, the display format was set to text, and you can't multiply text. That's why we got 0. I'll undo this. I'll cancel editing the sketch. I'll go back to the table. Alright, and I'll change all the original values back to the numeric values. Here, and I will set it once again. This particular value is precisely equal to this, multiplied by a factor of 2. Now let's also link the height of the cylinder to our calculations. Let's proceed to open the window, meticulously clear everything from this particular area, and then carefully set the precise height of the cylinder to be exactly equal to the measured length of its foundational base. Subsequently, we will subtract, let's say, a specific value of 45 units. Like this. Now, this particular value will be 255. Let's exit the table, and then it will automatically update, as you can clearly see at this point in time. Now we have a cylinder with a length of 255. If I were to now, for example, meticulously change the width of the base by carefully editing the properties within the table and then proceed to set the precise width of the base not to its original measurement of 150 units, but instead to a significantly larger dimension, let's say 250 units. I'll exit the table. And look, the length of the base and the height of the cylinder have increased according to the relationships we set between the dimensions. Just like that. That was tables in SolidWorks. This was Alex Eftefiv with you. Subscribe to the channel and give this video a like. Goodbye everyone.